Welcome to this comprehensive tutorial on building data models with Avro. In today's video, we'll explore what Apache Avro is, why it's essential for data serialization, and how you can use it to create efficient data models in your applications. Let's dive right in. First, let's discuss the basics of Avro. Apache Avro is a framework developed within the Apache Hadoop project that provides a binary serialization format along with a rich data structure dynamically interoperable with multiple programming languages. It's particularly useful for working with big data technologies. With Avro, you can define your data models in a straightforward JSON format, which makes it easy to understand, maintain, and evolves over time. Let's look at an example Avro schema to see how we define it. In this schema, we define a record named user, which includes various fields including a username as a string, age as an integer, an array of strings for emails, and a map that represents phone numbers. Note how users can have multiple emails or phone numbers, reflecting real-world scenarios. To use this schema in your application, you'll need to integrate Avro into your Java project. You can do this with Maven by adding the following dependencies in your pom.xml file. Now that we have our schema and dependencies set up, let's move on to actually generating Java classes based on our Avro schema. This can be done using the Avro Maven plugin. Here's how to configure it in your Maven build. Add this plugin configuration to your pom.xml file, and the Java classes for your Avro schema will be auto-generated when you build your project. Next, let's generate that Java class for our user schema. Once we've added the Maven plugin to our pom.xml, we can now run a Maven build command to generate the Java files. Open your terminal and execute the following command. After the build process completes successfully, you should see the generated user.java file located in the target/generated sources/Avro directory of your project. Let's check out what the generated class looks like. As you can see, the generated user class has all the necessary attributes and utility methods such as getters and setters, making it easier for you to work with your data. Now, let's move on to serializing and deserializing our objects using Avro. We will start with serialization. To serialize an instance of our user class, we need to create a binary file using Avro's data file writer. In this code, we create an instance of user, set its properties, and write it to a file called user.avro. This file now contains the binary representation of our user object. Now, let's move on to the deserialization process. To read back the user object from the Avro file we just created, we use Avro's data file reader, which will allow us to load the serialized data into our objects. Here, we read the user.avro file and deserialize it back into our user object. The deserialized user will now contain the user's data as it was originally defined before serialization. So, we've covered how to define an Avro schema, generate Java classes from this schema, and how to serialize and deserialize objects using Avro. Now, let's explore some advanced topics such as schema evolution and how to handle them gracefully. Schema evolution in Avro is powerful and allows you to change the data schema without breaking compatibility with existing serialized data. This is crucial in real-world applications where data evolves over time. Let's understand a simple scenario. What if our user schema needs to include a new field, say address? With this new field, we can still read old user records that were serialized with the initial schema, as Avro will simply ignore the new fields when they don't exist. However, when reading older serialized data, we might not have data for this new address field. To manage this, we can set a default value for address during our schema definition. By defining the field as a union that includes null, we ensure that if no address exists in the serialized data, our code will handle it appropriately without throwing exceptions. Another important topic is the backward and forward compatibility of your data. Backward compatibility means that a reader that understands the new schema should be able to read data that was written using the old schema. Forward compatibility implies that a writer can create files that can be read by a reader using a newer schema. By adhering to Avro's schema evolution rules, such as adding optional fields for new attributes, preserving field names, and managing existing schema data, your applications can evolve without losing access to historical data. With the theoretical knowledge behind schema evolution clear, let's also see how we can apply multi-schema support for complex applications. In some cases, you may require multiple schemas to interact seamlessly within your application, allowing various data models to engage coherently. This can be achieved by defining separate schemas in a logical way. In this example schema, we define a transaction record which contains an ID, amount, and a user field which references our previously defined user schema. This allows you to create relationships between entities effortlessly, which is beneficial for scenarios like integrating user transactions into your data model. Now, let's discuss the performance implications of using Avro. Avro is designed for high performance, particularly in big data processing pipelines. The compact binary format means smaller file sizes and faster serialization and deserialization times when compared to other data formats like JSON or XML. Another performance optimization can be achieved by using schemas compactly and avoiding deep nesting unless absolutely necessary, as this not only simplifies the schema but also enhances performance by reducing processing overhead. As a best practice, leverage the Avro tools provided for schema validation. This will help guard against potential issues arising from schema mismatches or errors during data processing. You can use the command above to validate your schema definition files against the Avro specification, ensuring that your data models remain consistent and correctly structured. To wrap up this segment, Avro not only provides a simple approach to data serialization, but also empowers you with significant flexibility in managing and evolving your data models. Whether you're working in distributed systems or building data-driven applications, Avro stands out as a robust choice. To conclude, thank you for following along with this tutorial on building data models with Avro. We covered defining schemas, code generation, serialization and deserialization, schema evolution, and performance tips. I hope you feel more confident in your ability to integrate Avro into your Java applications. Before you go, don't forget to like this video and subscribe for more programming tutorials. Also, drop your questions and comments below. I love hearing from you and will be happy to assist.